Okay, I'll try to move through this quickly, be thorough, and not try to bore you. I have my view builder set up to where this view file will show my safeties. This, of course, is not part of the icon file, but this is something you'll set up yourself in view builder, however you want to see this when you go to the home page. And you may not want to, but I like to have it on here. Let's go to our properties page, IO points. When you put this logic block that I've written into your logic of your program, you're going to get this show up, this safety signal, and this is what you're going to want to make sure all of your settings are correct so that this card works correctly. The first thing you want to change is you want to make sure this says 0 to 5 volts under the type. Linear full range, the minimum 0, maximum 5 with a resolution of 0.1. It's very important that these get set up correctly, and of course that you have the right input number. For this analog input, we're using number 1. In my case, you can use any of them you want as long as it reads voltage. Do not forget to change your jumper on your hardware to read volts. It may be on thermistor or something else. Just make sure that it's reading voltage. Very important. Okay, real quick on the logic page. Here's our analog safety signal. Right now we're reading 0.1, and we're going to read between 0.1 and 0.2 when there's no faults. Now, why are we not just reading 0? Well, I wanted to put something in the card that would be used kind of like a communication confirmation signal, so we know the card is plugged in. If the card were to come unplugged either at the ALC module or at the card, this would drop to 0 and it would lock out the compressors, because that's important. That means it's no longer reading high pressure switch, low pressure switch, and the unit could keep running with no charge or with a restriction and cause major problems. So you want to know if this thing's plugged in or not, if it's working or not. And so that's the purpose of this minimum signal of 0.1. And it's also important to remember to check to make sure that all of these delay on make blocks, all 5 of them, are set at 2 seconds. 2 seconds. 2 seconds works perfectly to allow the voltage to level out at whatever voltage level it's going to be at when the safety trips. Without that, if you put 0 seconds in there, or even 1 second, occasionally will still not work. We want 100% accuracy, so we change it to 2 seconds. But what this would do, if you change this to say 1 second, is it might not let that voltage climb at the speed that it climbs, or that the ALC hardware is able to read it at. And so this voltage on its way up to say 3.5, which would show a freeze stat failure, it may slowly climb, and when ALC reads it in that first second or half second, it may only be at 2.5 volts, and that's going to throw the wrong safety. It'll still lock out the unit, but the purpose of this card is to show you with a single input, enable you to see which safety tripped and when it tripped. So that's the purpose of the 2 seconds, is to make sure we get an accurate reading on that voltage level that's going to be coming through as it climbs. It climbs quickly, but it does climb, and so we want to give it time to be accurate. Now, speaking of seeing when it tripped, that's what these trends here are for. Now, you'll have to enable the trends. They'll by default show up on the disabled points, and after you enable them, they'll show up on the enabled points, and you can trend them. So that will be, so when it trips, like let's say you check the unit in the evening, you see the room is red or whatever, and one of these will say fault, and it'll say fault on your graphics page as well if you've set that up. You will be able to go in the trends and see when it tripped. You'll see that the low pressure tripped early that morning when it was cold, and you'll think, maybe we're just a little low on charge and the pressure's dropping, or maybe we need to install a head pressure switch or something like that because it's just in the mornings that it's tripping on low pressure and it's cold outside. That's the purpose of this. You'll be able to see when it tripped, and you'll know exactly which one it tripped, or which one it was that tripped. These right here may come default as off and on, and I've changed those to default and normal because that's what I want to see on my graphics page. But the program may have it by default as off and on, and you'll just change those to normal and fault. Fault would be the active text, and of course the inactive would be normal. And whatever text you put in there is what's going to be on your graphics page after you in View Builder set it up to read that point. So that's pretty much all you need to know about the logic. Of course, this is how you would reset it. When one of these are faulted, you'll actually see the latch output on shows you which one it was that faulted. Of course, you could also trace these back to see where they're reading from, and you'd be able to see which one tripped. But to reset, you'll just see right after the latch, it'll say on. Matter of fact, let me trip one right now. Let's say, like low pressure switch. I'll just flip that off. Okay, I heard the safety, I heard the compressor output click. Okay. Yeah, so it actually happens in the field on the card quicker than you're going to see it on your graphics, because there'll be some times that you're like, man, I don't want my unit running that long with the high pressure switch tripped. Well, trust me, in the field, it happened a lot quicker than you saw it on your graphics. If you set this up in a lab, you'll be able to see that. Okay, so a low pressure switch is tripped. Okay, now notice this little jump over right here. The purpose is, watch this. If I reset this, okay, that's all it takes. It's a momentary switch. That's all it takes to clear this latch. Okay, now when I reset this, this is going to reset. Okay, yeah, see, that took a second, but that's all in the happening in web control, those delays, not in the field. So this is still on. That's why we still have an alarm even though I've reset it. And that's the purpose of this little leapfrog here, is you don't want to be able to reset this if the safety switch in the field has not physically reset. Okay, so I'm going to reset that low pressure switch, and now the compressor can come back on. So even if you reset this part first, there's a backup safety that says unless that safety in the field has physically reset, nobody can come in here and force this compressor to run. Of course, without doing more work, it could force this compressor to run unless that low pressure, high pressure switch has actually reset in the field. Okay, that should be about it. Now to look at the card. Okay, so we'll start with the power input. Of course, everything's labeled clearly. We got 24 volts in, and we have our common here. Just make sure you get your polarity correct if you're going to bring this terminal here to the chassis, which you don't have to do that. Some people just want all of their boards ground plane to be at equal potential with the chassis. You don't have to do that. Don't worry about that. That's really just there. It's more of a for testing purposes. And that terminal will be there on the other model of this board that I'm creating that have the condensate sensor. Instead of the switch type, it'll be a sensor type. And so you'd have this terminal here equal with the chassis, and then that sensor, of course, will be detecting water. Yeah, don't worry about that. And this is where our safeties are going to plug in. Have them marked S1 for safety loop 1, safety loop 2, 3, and 4. And they're just in pairs. So this would be 1, 2, 3, and 4. And they're going to come with jumpers like this one I have hooked up already. If you don't use a safety, you need to keep the jumper connected. So let's say you're just using 3 out of the 4, then the 4th one you're going to want to leave jumpered out. This is a test switch bank, and what that's for is if you switch one of these switches off, then that simulates that particular safety loop opening. So if I turned off switch 4, that's going to simulate safety loop 4 becoming open. Now, in order for it to read true open and closed, it has to be in the on position. So these should always be in the on position, unless you're out in the field and you're wanting to just do a test without having to get your screwdriver out, loosen a terminal, pull the wire out, test it, put the wire back in, tighten it back up. They're just convenient switches. It just simulates that loop going open without having to physically open the loop. So just there for your convenience. And then we have our analog output, which will go to your analog input of your controller. Just make sure that you have your polarity right, that this top terminal here is going to go to an analog input ground, and then your analog output here is going to go to an analog input of your controller that you're reading from. As I mentioned before, make sure that you change that jumper on the hardware itself, whether it's automated logic or Delta controls, whatever, that you change that jumper to read voltage and not thermistor or milliamps or something like that. Make sure it's set up to read voltage, 0 to 5 volts. And that's pretty much all there is for the hardware. Just a quick summary of what all this stuff is. This is our power supply. We have an inductor, some capacitors, voltage regulator, some diodes. That gets us from 24 volts AC to a voltage we can work with an integrated circuit like 5 volts DC. That's how we regulate and step down. We have a bunch of resistors here that essentially is just a bunch of voltage dividers. And this IC here, of course, is a voltage comparator. And then we have some diodes here to make sure that things don't backfeed. And that's all there is to this board. It's very, very simple. It's not rocket science. As far as mounting the board, you need to use standoffs. So you will have to mark your holes, drill them with a 3/16 drill bit. A 3/16 drill bit will allow you to go into the sheet metal, and this will pop in and stay in place. But you have to stand this off. Obviously, you can't put this board with all of its solder connections on the back on a metal chassis and expect this thing to work. Not going to work. You have to use these standoffs of some sort. They make these with sticky back that you can order, but I like something that's not, I don't have to worry about falling off, and so that's why I recommend these. 3/16 drill bit. Alright, we're going to do a brief demonstration. I've got this hooked up to a ZN551 card, simulating a water source heat pump, and I'm going to simulate one of the safeties going out. I heard the click, and now it's in fault. Okay, we can see that that was the second switch, which I have set up as the high pressure switch. Now, high pressure switch makes back after the compressor shut off, pressure's level out, pressure switch makes back. This is going to stay in fault mode until we go to the logic page and reset. Right here we can see this is faulted. Okay, that goes to this latch here. You can just look at the latch block, whichever one says on immediately after the latch, that's the one that was tripped. Hit reset. This is a momentary switch, which means you just click here to reset and apply or accept, and it will automatically go back to reset. So it's just a momentary switch. That resets. I already heard my compressor output click back on. This all happens in the field a lot faster than it happens on the graphics. So, all right, so then we'll go back to our graphics page. We can see that we are normal again All our safeties are normal. And we'll do one more. Let's do the safety 4, which I have set up as the condensate switch. I heard my compressor click, and now we have condensate switch fault. All right, reset that switch. This is going to stay faulted, so when the technician pulls up, see why it's not working, he sees that safety switch 4, or what we have as condensate switch, is in fault. He'll go to the logic page, and he can reset it from here. Click reset. And as long as the switch is reset in the field, or has physically closed again, this will reset and allow the compressor to come back on. And of course, we can trend this enabled points. Let's look at our low pressure trend, because I think I've reset this since we've been doing this. Yeah, so we can see here, the first time the low pressure tripped switch was at this point right here, and then it was reset. So at this time, you can see when it was on, and you can see when it was off. So this will be very useful to see when these safeties tripped.